Hello and welcome to our video extravaganza about angles. So today this is just going to be an informational video to help you get some good notes and to give you guys a better idea of how angles operate so you can use it in your math class. So let's go ahead and define an angle. So an angle, if you want to take notes, is a figure formed by two rays sharing a common endpoint. And that's kind of a very technical definition. You'll see what we're talking about when we start discussing types of angles. So we'll go ahead and pop up our little chart. Here we go. So there are 5 different types of angles. There are congruent, acute, right, obtuse, and straight angles. And we have the definitions here if you guys want to write them down. We are going to be going through some pictures also just to kind of give you a better idea. So we'll start with congruent angles. So the definition is 2 angles with equal measurement. For example, we will just say, let's say we'll go with a 90-degree angle. So if we're trying to create a 90-degree angle, here is our 90-degree angle. So this is a ray, and this is a ray, and here's the common endpoint that they share to form this angle. And since it's 90 degrees, we indicate that with a little box, like so. So this is our 90-degree angle. If we were to have 2 angles that are congruent, we would just draw in a second angle that was 90 degrees. And this one could be bigger than this one or smaller, but if they're both 90 degrees, they're considered congruent angles. And we're going to indicate that with our box just so we know that they're the same. Great. So now that we have a good understanding about that, acute angles are angles between 0 and 90 degrees. So let's start with a 90-degree. We'll start with a 90-degree kind of outline. That way we can get a good idea. So here's our 90-degree outline. If we want to make an acute angle is going to be anywhere in this area between 90 degrees and 0 degrees. So it could be 1 degree, it could be 89 degrees, just anywhere in between. We'll go ahead and attempt to make a 45-degree angle right there. And we'll make it a different color just so it really stands out. So this would be considered an acute angle because it's between 0 and 90 degrees. Now a right angle is exactly 90 degrees. And that doesn't change. So it's not relative. It's just always 90 degrees, which is nice to know. So here's our 90-degree angle, as we've seen before. Not a big deal. We'll go ahead and color this just so we get a good idea. Perfect. Now an obtuse angle is an angle between 90 and 180 degrees. So if 180, which as we'll see with a straight angle is considered a straight line, we'll make our 90-degree outline again here. So here's our 90-degree outline. If we want an angle to be obtuse, we are going to go past this 90 degrees. So 91 degrees, 100 degrees, 140 degrees, anything past here is going to be considered obtuse. So let's pretend this is 130 degrees, this angle right here. So this is going to be considered an obtuse angle because it goes past that 90-degree marker. Now, a straight angle can be kind of complicated because it's really just a line. But a line is an angle, nevertheless. So it's going to be this straight line right here. So we measure angles in degrees of 180. So here would be 0, and we know 90 would be our marker up here, as we've seen in the pictures above. And then right over here isn't going to be 0 again. It would be 180. So if we came all the way around, this would be 180 degrees. Perfect. Okay. So now that we have that down, let's talk about let's talk about how we measure angles that are seemingly past the 180 degree marker. So let's start with our straight angle right here. You can kind of think of it as a horizon. That's what helps me out. So we'll even make you a little sunset. How about that? Here's a sunset. And we'll color it yellow for you. Ah, beautiful. So let's say here's the sun setting on our horizon right here. And this is our 180 degrees. Some people may be a little bit confused because they'll start with an angle right here and say, okay, if I go all the way over here, blah, blah, to 180 degrees, if you go past that, is that 190, 200? That is no longer how we measure it. So let's say we had an angle that started here and wrapped all the way around past 180. Well, we're going to measure that angle as if it started from this point right here. So things aren't going to go past 180 degrees when measuring angles. It's going to be started from right here, and we'll just measure that part right there. So from this line, the 180 degree line, let's say this is 45 degrees lower. So it would be 180 plus 45. That'd be, oh gosh. Okay, let's say it's 190 because 10 is easier. So let's say this is 190 degrees. We would now measure this as 10 degrees because 190 minus 180 is 10. So this is only 10 degrees past our little horizon, if that helps you guys at all. This is going to be helpful when we are learning about vertical angles. So a vertical angle are a pair of angles opposite each other. Wow. Formed by two intersecting lines. And it's also called an opposite angle. Just to make life easy, because some people will call it an opposite angle. Okay, let's attempt to draw this. So let's say we have two rays. Here's one, it's going to go straight down, and then we'll make another intersecting one. Great. So because we have these two rays, we have four potential angles. And what we're going to want to understand is that this angle right here and this angle catty corner to it are equal. So these would be the same degree. And likewise, this angle right here is going to be the same as this angle over here. I know my lines are beautiful, but we'll go ahead and indicate this with colors. So the two red angles are going to be the same measurement, and then the two green angles are the same. And if this is kind of complicated, let's go in depth, because we want to prove that this angle right here is equal to this one and that this one is equal to this one. So let's go ahead and call this angle A, and we'll make this angle angle B, and this angle angle C here, and then another, last but not least, angle D. So we have angle A, B, C, and D. So let's look at A and B for starters. So A and B, both of these angles rest on this ray right here, and I'll see if I can highlight it for you. Yes, so angle A and B rest on this yellow line together. And so remember, up here we learned that this 180 degree line is a straight angle. So a line is 180 degrees. So if we know that this angle plus this angle has to equal 180 degrees because they're both on a line. So we'll put A plus B equals 180 degrees, right? We can buy that. Super, super simple concept. But as we know, you can kind of exchange these. So if we want to find A is equal to 180 minus B. That makes sense, right? So if A and B both equal 180, let's take a look at this line right here. So now our blue arrow. Well, C and B both rest on this blue line, right, underneath, as do A and D. But let's look at B and C. So if they both rest on this blue line, that means B and C must equal 180 degrees, because that's the same thing we just said for A. You'll just have to tilt your head a little bit. So we know that C plus B is now 180 degrees. And likewise, that means C equals 180 minus B. Okay, so let's take a look at this. So A is equal to 180 minus B, and C is equal to 180 minus B. And if that's the case, A is congruent to C, because they equal the exact same thing. And if that's the case, then A and C are considered vertical angles. Super simple, but some people like to overcomplicate that a little bit. So that's how we know that vertical angles can exist in that way. Great. So next what we're going to be talking about is something that's, something just a little bit more complicated, and that's the parallel postulate. And I promise it sounds a lot scarier than it really is. Like, this definition is going to blow your mind, but we'll break it down so it's a lot easier. So the parallel postulate states, if a line segment intersects two straight lines forming two interior angles, summing to less than 180 degrees, the two lines, if extended indefinitely, this is important. If extended indefinitely, meet on that side. And as scary as that sounds, it's actually very simple. We'll just show an example. So let's say I have a ray right here, a vertical ray. And then I add two horizontal rays that are parallel to one another. Not a big deal. That means that this angle equals this angle will equal this angle, this one equals that one, like we learned before when we were talking about vertical angles. So this angle is the same as this angle right here. Oops, and I know my lines are just so beautiful. So this is the same as this, and this would be congruent as well. And since we were able to prove our vertical angles, we know that this one is congruent as well. So if these are all parallel, all the exact same, then we have these equal angles, and these will go on being parallel forever if they were to continue. The parallel postulate says that, for example, if we have another vertical ray with two intersecting rays, and this one were to go at this angle, and this one at this angle, the parallel postulate says that if this angle and this angle don't sum to be 180 degrees, then they will intersect. And let's break that down a little bit easier. So let's say this angle right here plus our angle over here, because you know our vertical ray equals 180 degrees. This one right here, we'll highlight it for you. We know that this equals 180 degrees. Well, if these angles don't add to equal 180 degrees, as is on this line, we know that these two angles, this arrow, we'll make it red, this red arrow and this green arrow, we know that eventually these two are going to meet. So if this one is extended forever, and this one is extended forever, they're going to cross and become perpendicular at some point because these two angles don't measure to be 180 degrees because they're both less than 180. Does that make sense? I hope so. So these lines are parallel, these lines are not. Therefore, parallel postulate. Great. Fantastic. I think that was our main, idea. Fantastic. So now what we're going to look at is we're going to be looking at trying to use this practically. So what we have here is called an angle chase problem. And because what we know about vertical angles and parallel postulates and straight, acute, and obtuse angles, we can find the missing letters. So A, B, C, and D are what we're going to solve for. And we've been given several different angles. So what I'm going to do is I'm going to allow you to pause this video real fast. I hope you've been taking notes so far because they'll come in handy. So you're going to pause this video and then work out what you think A, B, C, and D are. And then we're going to come back together and share answers, and I'll talk you through it. So go ahead and pause the video. Go for it. We'll make it like a solid few-minute pause, just so you can work it out. Okay, great. Welcome back. So to solve for angle A, we're going to look at line CD because it's going to go right through here. So what we know about straight angles, and this is a straight angle, is that it equals 180 degrees. So we have 118 right here. So if we were to take 180 minus 118 and solve for that, we would get, that's right, 62 degrees. So we know that A equals 62 degrees. Great job. Now B. B is on this line right here. As you can see, it runs this way. So if we're looking at B, 180 degrees is over here, and here's B. So these two would add to equal 180. So it's going to be the exact same thing. 180 minus 118 equals 62 degrees for B, because they both rest on this line also. It's just you turn your head and you'll look at it as if it's just these two. So B is also 62 degrees. So now that we know these two, we take a look at C, and triangles add to equal 180 degrees also. So since we have A and we have this second angle over here, 62, we can solve for C. So we would take 180, which is the total triangle, minus 62, which is given right here, minus 62, which is A, and the other angle that completes this triangle. And that is going to equal 56. So we know that this is 56 degrees for angle C, which is awesome. You guys are so smart. Now D. D is our last one. So like we said before, a triangle equals 180 degrees. So it's going to be this angle plus this angle plus this angle equals 180. Well, we have B and we have this over here. So we're just going to go 180 minus 67, which again is right here, minus the answer to B, which was 62, equals, calculate it if you haven't already, I'll give you a chance, 51. Great. So 51 degrees. So now we've solved for all of these, and it's all because we knew about our different angles. See? Great. So thanks for watching, guys. There are some great word problems that you can work through with angles. If you want me to post another video about it, I can. But hopefully you learned something, and great. Thanks so much for watching.